Hello my dear students, good morning to all of you and welcome to e-learning classes of Holy Child English Academy, and I am Mr. INJAMUL SIR present here to take your maths class, and today I will take the class for the students of class 10, and in my class I am going to discuss about the chapter arithmetic and geometric progression, and in short arithmetic progression is known as AP and geometric progression is known as GP. Actually, this class is very important for the students of class 10 as well as student of class 11. Okay, this chapter you will get again in class 11. Okay, so you should pay your maximum attention as much as possible. So let's go today's class. Before going to my main discussion, I would like to share and I would like to introduce you with some definition on some terms which I need to explain this chapter. Okay, so let's go. The first term is you have to know about pattern. Okay, I hope all of you know about the pattern. So what is pattern? Pattern means a frame, a transformer. Okay, suppose this is a transformer or a converter, and this is the place of this is input device and this is suppose output device. Okay, this is our input device and this is our output device. Suppose if we consider a rule or pattern fx equals to 2x plus 3, then this is a frame. Okay, how this is a frame? If you put a value of x, suppose if we put x equals to 1, then this pattern will give you a number. How? Just put x equals to 1, then it will get 2 into 1 plus 1 equals to 3. For x equals to 2, you will get again a number. If of 2 equals to 2 into 2 plus 1 equals to 5. So we can say that this is a pattern or this is a rule also. Okay, so pattern means in simple or in rough word a frame in which if you give any input, then you will get output. Similarly, suppose I am considering a pattern Tn equals to 2n square. Then if this is input device and if you put the value of n, suppose for n equals to 2, if you give input n equals to 1, then you will get output. This is a machine, so you will get T1 equals to 2 into 1 square. That means ultimately you will get 2. Okay, so if you give input as n equals to 2, then you will get T2 equals to 8 and as so on. Okay, so Tn is a pattern, is a rule. Understood? So this was the concept of pattern. Next term is sequence. A sequence is a pattern or a rule for which or in which for every natural number you will get a real number. Understood? For every natural number you will get a real number. The numbers 1, 2, 3, 4 and so on. These numbers are called natural numbers. Okay, so I am writing the definition sequence. A sequence Okay, we can give the definition of sequence into this way. That sequence means a sequence is a rule or pattern which gives a real number corresponding to every natural number. That means if you give input a natural number, then always that pattern able to give back a real number. Okay, then that pattern or that rule is called a sequence. Is it clear? Next, some examples. Suppose Tn equals to 2n plus 3. Then clearly this is a pattern. Okay, this is a frame. So now check that for every natural number, this pattern able to give a real number or not. If this pattern gives a real number corresponding to every natural number, then this must be a sequence. So for n equals to 1, we get t1, and t1 will be 2 into 1 plus 3, that means 5. For n equals to 2, t2 equals to 7. n equals to 3, for n equals to 3, t3 equals to 9, and so on. It will be going on. Okay, so we can say that this is a sequence. Since for n equals to 1 we get t1 equals to 5, it is a real number. It is also real number. It is also real number, and you will get real number only. Okay, so this is the sequence. But if you consider another pattern, tn equals to 5 n by n minus 2. Now check, this is a pattern. We have to check whether it's found a sequence or not. So for n equals to 1, you get t1 equals to 5 by minus 1 equals to minus 5. So itself a real number. n equals to 2, t2. t2 means 5 to the 10 by 2 minus 2 equals to 10 by 0. 10 by 0 means it is undefined. It is undefined and undefined. So this is not a real number. This is not a real number. Okay. So this pattern fails to give a real number corresponding to the natural number 2. So this can't be a sequence. This is not a sequence. Okay. Hope you get the idea about sequence. When does a pattern is said to be a sequence or not? Clear? So first you have to know which numbers are not a real number. Actually in mathematics, if denominator is 0 in a fraction, then that number is undefined, and undefined means the number has not been defined. So this is not a real number. Okay. One more important thing is there about real number. If within square root any negative number is there, then that number is not a real number. As for example, suppose within square root if we consider minus 9, okay, then this is not a real number. That means within square root if a negative number is there, then that is not a real number. Okay, for your better understanding, I am considering one more pattern, and we have to check whether the pattern is a sequence or not. Okay, suppose tn equals to root over 6 minus 2n. Okay, 6 minus 2n. Now we have to check that this pattern is a sequence or not. How to check? If this pattern able to give real number corresponding to every natural number, then we can say that this pattern is a sequence. So let's go. For n equals to 1, n equals to 1, t1 equals to root over 6 minus 2. 6 minus 2 means root over 4, and root over 4 equals to 2, and it is a real number obviously. Next, for n equals to 2, for n equals to 2, t2 equals to root over 6 minus 4 equals to root over 2, and root over 2 also a real number. Okay. Now for n equals to 3, t3 equals to root over 6 minus 6 equals to 0, and 0 itself a real number. For n equals to 4, t4 equals to root over 6 minus 8 equals to root over minus 2. And as I told just before few minutes that within square root if a negative number is there, then that number can't be a real number. So this is not a real number, is not a real. So we conclude that this pattern fails to give a real number for n equals to 4. Understood? So we conclude that this is not a sequence. Not a sequence. Just remind the definition of sequence. If a pattern able to give a real number corresponding to every natural number, so here n equals to 4. So for n equals to 4, we did not get a real number. So this is not a sequence. Okay. Actually our main topic is arithmetic and geometric progression. So now you have to know about progression. What is progression? In simple word, progression means a group of number. Suppose you have a group of number and that group of number is said to be a progression if those group of number follows some pattern or follows some rule. That means you can predict about the next term. Understood? That means you can make a rule for that group of numbers. I am considering some example, then it will be clear to you. 2, 4, 6, 8, 10 and these 5 numbers. Okay, so this is a group of number and this group of number follows a pattern or a rule, and if I ask you about the next one, then easily you can give the answer. What? That's the next one will be 12. How? 2, 4, 6, 8, these are the even number. Understood? So what will be the pattern for this group of data or group of numbers? Actually Tn equals to 2n. This is the pattern which follows by this group of numbers. Put n equals to 1, then you will get the first one. For n equals to 2, you will get the second one. For n equals to 3, you will get the third one. For n equals to 4, fourth one, and n equals to 5, fifth one. Understood? In rough word, we can say that suppose we have a sequence. Suppose we have a sequence. Tn equals to 5n plus 2. And if we expand this sequence term wise, then the expanded terms are called progression. That means if we expand it, then T1 equals to, you will get 7, T2 equals to 12, T3 equals to 17, T4 equals to 22 and so on. So if we write this number, then 7, 12, 17, 22 and it will be going on. Okay, so this is a group of numbers and this numbers follows this pattern. Okay, so we can say that this is the progression. This is progression. Okay, and we are present here today to discuss about arithmetic and geometric progression. So you got the idea about progression. Now what is arithmetic progression and what is geometric progression? This is the question. On the basis of some special characteristic, we will give a particular name to a progression. Okay, so let's go. Okay, I have considered here some sequences. This is the first sequence, second, third. Okay, now we'll expand it. That means we'll convert these sequences into progression. Okay, so expand term wise, then T1 equals to 5, T2 equals to 7, T3 equals to 9, T4 equals to 11, T5 equals to 13 and so on. If we expand it, then T1 equals to 2, T2 equals to 8, T3 equals to 18, T4 equals to 32 and T5 equals to 50 and so on. Here T1 equals to 1 by 3, T2 equals to 1, T3 equals to 3, T4 equals to 9, T5 equals to 27 and so on. Okay, we have considered here 3 sequences. Then we can say that 5, 7, 9, 11, 13 these are in progression. 2, 8, 18, 32, 50 these are in progression since this group of number follows this pattern. And 1 by 3, 1, 3, 9, 27 this is also a progression. Okay, but among these 3 progressions, see the first one. Then you can observe that for the first one there is a special characteristic among the terms. Okay, so what is the special characteristic? See, from 5 to 7, that means first term to second term, we will get by adding 2. Okay, for second to third, we will get by added by 2, and again for next again by 2, again by 2. So for any term to next term will get by added 2. So this is the special characteristics there. Okay, that means if you consider any two consecutive terms, consecutive term means a term and next term. So if you consider any two consecutive terms, then you will get the same difference. Okay, suppose you have considered 11 and 13. So their difference is 13 minus 11 equals to 2. Okay, and suppose 9 and if we consider these two terms, then 9 minus 7 equals to again 2. So if you consider any two consecutive term, then you will get the same difference. So this is the special characteristic. But this characteristic is not in the case of second sequence. Understood? But for the third sequence, there is also a special characteristic. What? See, from first term to second term, we get multiply by 3, and for this to this again we get by multiply 3, this to this again by 3, and this is again by 3, and it will be going on. So there is a special characteristic and there is also a special characteristic. So for this special characteristic, if we consider the ratio of any two consecutive term, in this case we have considered the difference, since here we have added, we get by added a fixed number, but here we get the next one by multiplied a fixed number. So if we consider the common, if we consider any two consecutive term, then we will get the same ratios. Okay, so this special series, this special progression is called arithmetic progression. Arithmetic progression. And this special progression is called geometric progression. Geometric progression. Understood? So what is arithmetic progression? The definition should be like this, that in a progression, if the difference of any two consecutive terms remains same, then that progression is called arithmetic progression. Or you can memorize into this way also. To get the next term, we have to add a fixed number. If we can observe this characteristic in a progression, that to get the next one, if we add a fixed number, then that type of progression is called arithmetic progression. And the concept is, if we to get the next one, next term, if we multiply a fixed number, then this is called geometric progression. So arithmetic progression and geometric progression, basically this is for addition, that means if we add a fixed number, and geometric progression, this is based on multiplication, that means to get the next one, if we multiply a fixed number with the previous one. Okay, so this is the introduction of geometric progression, and this is the introduction of arithmetic progression. Okay, hope you get the idea that what is arithmetic progression and what is geometric progression. Okay, my discussion will be continuing on arithmetic progression. Okay, before continuing about arithmetic progression, I am considering one more example of arithmetic progression. Okay, I am considering here, suppose here 7 minus 4n. Now expand it term wise, then t1 equals to 7 minus 4, that means 3. t2 equals to 7 minus 8, that means minus 1. t3 equals to minus 5. t4 equals to minus 9. t5 equals to minus 13, and it will be going on. Okay, see, there is also a special characteristic among the term. What? From this term to this term, we have added minus 3, added minus 4. Why? 3 minus 4 means minus 1. From this to this, again we have added minus 4. Okay, added -4 or subtracting -4, same thing. Subtracting 4. Okay, from this term to this term again -4. From this term to this term again -4. So on the basis of this characteristic, also we can say that these terms are follows arithmetic progression. Okay, since if you consider any two consecutive terms, then you will get the same difference. Okay, so this is also example of arithmetic progression, and this fixed number which we are adding to get the next one, this fixed number is called common difference. Since you will get the same difference if you consider any two consecutive terms, so you can name this number as common difference. Common difference. So here common difference is -4, and in this case common difference is +2. This is our common difference, and common difference is denoted by small d. Okay, and here first term is 3, but for the this progression first term is 5, and first term is denoted by small a. So today's our discussion will be continuing on arithmetic progression. So you get the idea that you can generate a arithmetic progression if you are having the first term and common difference. Suppose I am giving you 2 as a first term and common difference is 5. Suppose I am giving you 2 as a first term and common difference 5. Then easily you can generate the progression. How? Since first term is 2, and give common difference is 5, so you can generate. So first term 2, to get the next one, since common difference 5 is given, so you have to add 5, so it will be 7. After that again add 5, then 12, again 5 add, and so on. So this is the progression, arithmetic progression. Okay, so only if you have the first term and common difference, then you can generate the progression. Is it clear to you? Okay, I will discuss later about geometric progression, but today we will continue with arithmetic progression. Okay, next, in an arithmetic progression, first term equals to 5 and common difference equals to suppose 2. Okay, and if I ask you about the fourth term, then easily you can say that what will be the fourth term. How? Sir, first term is 5, so next term we will get by added 2, so it will be 7, after that 9 and 11, so 11 is the fourth term. But if I ask you about 200th term, then is it possible? Is it possible to go through this way? No, it will be very time taking. So we have to generate a rule or a formula so that easily we can find out any term of the progression. Understood? So let's go. In general, we will establish the formula. Okay, suppose AP. Suppose in our AP, let first term is A and common difference D. Okay, just try to write the terms. Then first term is A, so second term we will get by adding D. If we add again D with this, then we will get the next term. So A plus D. So this is nothing but A plus 2D. Okay, so I am writing here A plus 2D. So next term will be again if we add D with this, so it will be A plus 3D. And next one will be A plus 4D. and it will be going on into this way. So now observe properly that this is our first term, this is our term 1, T stands for term, and this is 1. This is our second term, this is our third term, this is our fourth term, and this is our fifth term. So have you got any, did you get any idea? See, for the first term we have not added D, but for the second term we have added 1 times. For the third terms we have added 2 times. For the fourth term we have added 3rd times. For fifth term we have added 4 times. Okay, so easily you can say that for to get 10th term you have to add 9 times of D with A. So A plus 9D will be our 10th term. Understood? See, for the first one we have not added, but for the second term 1 times, for the third term 2 times, for fourth term 3 times, for fifth term 4 times. So for sixth term will be 5 times. Similarly for 10th term it will be 9 times. So from this concept we can generate a general formula that to get nth terms you have to add n minus 1 times. So A plus n minus 1 times of D. So this is the formula to find out any terms of the progression. Okay, so this is nothing but also sequence for this progression. Hope you get the idea. So next, in an AP, let 5 is the first term of an AP and minus 3 is the common difference. Then find find 21st term. Okay, this is the question. So solution will be what? Here clearly here first term is given, so A equals to 5 is given. Common difference D equals to minus 3 is given. You have to find out 21st term. So we know the formula for find out any terms. What was the formula? Just I taught you that Tn equals to A plus n minus 1 into D. Without this formula you can find out also. Why? For 21st term you have to add 20 times. So if you put here n equals to 21st, since we are going to find out 21st term, so T21st equals to A plus 21st minus 1 into D. Now put the value. A means here 5 plus it is 20 and D means minus 3. So 5 plus minus 60, that means minus 55. So this is the 21st term. So in this way you can find out any term of the progression. Hope you get the idea. Okay, in my next class I will be continue again. So today's class is up to this. So take care and goodbye.